Welcome to Daily Papers, the podcast where we break down the latest and greatest research into bite-sized pieces you can actually understand.
Today, we're talking about large language models, or LLMs, the brains behind things like ChatGPT. We all know they're incredibly powerful, but they have a slightly embarrassing problem.
They make things up. It's often called hallucination, where the AI will state something with complete confidence, even though it's totally wrong. It's like talking to a friend who has read every book in the world, but sometimes mixes up the details.
Exactly, and this is a huge issue when you need accurate, factual answers. So, researchers have been trying to solve this by giving these AIs an external brain, or a super reliable library they can check for facts. Today's paper introduces a really clever way to do this.
The paper is called KG Hopper, Empowering Compact Open LLMs with Knowledge Graph Reasoning via Reinforcement Learning. It's from researchers at Chalmers University of Technology in Sweden.
Okay, that's a mouthful. Let's break it down. The library they give the AI is something called a knowledge graph. What is that?
Imagine a giant interconnected mind map of facts. You have points, or nodes, which are things like Leonardo da Vinci or Mona Lisa, and then you have connections, or edges, that describe the relationship between them, like painted. So the graph contains the fact, Leonardo da Vinci painted Mona Lisa. It's a highly structured, reliable source of information.
So, instead of the AI just trying to remember everything, it can look things up in this giant fact map. Simple enough, but what's the catch?
The catch is that a lot of questions aren't simple lookups. They require connecting multiple dots. The paper calls this multi-hop reasoning.
A multi-hop question, like a detective following a trail of clues.
Precisely. The paper gives a great example. What is the official flower of the area affected by Tropical Storm Fabio? To answer this, the AI can't just look up Tropical Storm Fabio. It first has to do Hop 1, find out what area the storm affected. The knowledge graph says Hawaii.
Okay, so now it has a new clue, Hawaii.
Right, now it needs to do Hop 2. What is the official flower of Hawaii? It searches the graph again and finds yellow hibiscus, so 2 hops to get the answer.
And the traditional way of getting the AI to do this is not great. It's a very rigid step-by-step process. First, you ask the AI to find the location. It does a search, finds Hawaii. Then you use that answer to ask the next question.
The problem is that this method is very fragile. If any single piece of information is missing along the way, or if the AI makes one wrong turn, the whole thing falls apart. The paper calls this error cascading. It's like a game of telephone. A mistake at the beginning ruins the final message.
So, if the knowledge graph was missing the entry for Hawaii's flower, the AI would be totally stuck. It might even guess something completely random.
And that's where this paper's big idea comes in. KG Hopper. Instead of a rigid step-by-step process, they teach the AI to do all the reasoning in one single, fluid thinking phase.
So it's not just asking one question, getting an answer, and then asking the next. It's more holistic.
Exactly. The AI gets the full question, and then it can explore the knowledge graph freely. It can try one path, see it's a dead end, backtrack, and try another. It considers all the steps together inside one continuous thought process before it gives the final answer. It's much more like how a human would solve a puzzle.
That sounds way smarter, but how do you train an AI to think like that? It sounds complicated.
This is the coolest part. They use a technique called reinforcement learning. Think of it like training a dog. You give it a command, and when it does the right thing, you give it a treat. When it does the wrong thing, it gets nothing. Over time, it learns what actions lead to a reward.
So what kind of treats do you give an AI for being a good knowledge detective?
They designed a whole system of rewards. The AI gets a small reward just for deciding to use the knowledge graph, which encourages it to look things up instead of guessing. It gets another small reward for formatting its thoughts in a clear, logical way.
So it's rewarded for showing its work.
Yes, and then there are the bigger rewards. It gets a significant reward if its chain of reasoning is logical and makes sense. And finally, it gets the biggest reward of all if it lands on the correct final answer. Through millions of trial and error, guided by these rewards, the AI learns to become an expert at navigating these complex webs of facts.
Okay, so the theory is solid. It's a more flexible, intelligent way to reason. But did it actually work? What were the results?
The results are pretty amazing. The researchers built their KG Hopper model using a relatively small 7 billion parameter LLM. For context, some of the giant models out there are over 70 billion parameters, 10 times larger.
And this little 7B model, how did it do against the giants?
It consistently outperformed much larger models that were using the old step-by-step method. It was even competitive with huge proprietary models like GPT 3.5 Turbo.
Wow, so a smaller AI with a better process can beat a bigger AI with a clunkier process. It's not just about size, it's about strategy.
That's the key takeaway. It's like a well-trained detective with a library card, being more effective than a giant brain that's just trying to remember everything off the top of its head. By training the AI how to think and reason through a problem, you get far more accurate and reliable results.
So, in a nutshell, KG Hopper uses this clever reward-based training to teach an AI how to hop through a knowledge graph like a pro, connecting all the dots in one go.
And by doing so, it creates smaller, more efficient, and more trustworthy AI. It's a huge step towards solving that pesky hallucination problem and building AIs that we can actually rely on for fact-based tasks.
That's all the time we have for today. Thanks for tuning in to Daily Papers.